So, so guys, if I go back to the dependent motion for particles, the first step is to indicate the datum and then to know that the length of the slope is constant. And then what should I do? I should basically find the relation between displacement, derive it for velocity, derive it again for acceleration. Now what matters for me here is the equation of acceleration, right? So let's take a datum and put the equations for the acceleration. So if I take, in fact, my datum here and here, because I have two directions of motion, and then if I indicate this as AA, and this one here as AB, so I can, guys, I can put this AB to this center right here, because in fact this length is constant, right? Or you can extend it to here, it's the same, you're gonna have the same answer. So if this is AA and this is AB, or if this is SA and this is SB, and then you derive it twice, what will be the relation between them? In fact, for dependent motion, I know that SA plus 2SB is equal to constant. Then if you do the first derivation, VA plus 2VB is equal to constant, is equal to 0, and then you're going to have that AA plus 2AB is equal to 0. And here, guys, you have to pay attention to the direction. This AA is equal to minus AGX. Remember, what was the direction of AGX? It was to the right. While here, since this is my datum, in the dependent motion, you have to take S, or the acceleration, from the datum itself, which means here, this is your AA. And this means, guys, that even if I add an equation here that has a relation between AA and AB, I have two problems. First of all, AA is not AGX, it is equal to minus AGX. And second, AB is unknown. So what I'm gonna do, guys, is to replace this AA by what? By minus AGX, alright? If you keep it AGX, guys, you're gonna have a wrong answer. This is minus AGX because AA here is in the minus direction of AGX. So guys, minus AGX plus 2AB is your fifth equation. So let's go back. Now I have 1, 2, 3, 4, 5, and I have 1, 2, 3, 4, 5, but I'm adding an equation, an unknown, which is AB. So even, guys, if I add this equation right here, I still have a number of unknowns that is greater than the number of equations. Now I have 5 equations, but I have 6 unknowns. So what should I do? In fact, I have to find a sixth equation, or the equation for AB, in terms of the unknowns of my problems, all right? Because I don't want to add another unknown. How to find AB in terms of these unknowns? In fact, I can take the free body diagram of B. So what are the forces exerted on me? This is a particle, it's not a rigid body. I have weight, I have a tension, only, all right? I don't have any contact surface here so that I can add the friction force. There is no friction force because this particle here, B, is free, doesn't have any contact surface, which means, guys, the equation number 6 here is that minus t. So why I'm saying minus t? Because AB here is downward, right? So minus t plus the weight is equal to MAB. Or you can say T minus W is equal to minus AB if you want to take it positive in the positive Y direction. If you're going to take it, guys, positive in your positive Y direction, then this AB will be negative. All right? So this equation, guys, is the equation of AB in terms of the tension. But since the tension here, sorry, this is minus 2T because I have two parts of the rope, right? So I have this 2T that is equal to this T. So let's put here 2. Guys, if you take this pulley, these 2t is equal to this t, then this particle B is held by 2t, and then I have the weight. Right? So minus 2t plus WB is equal to MAB. Now here, I'm adding an equation number 6, but without adding any additional unknown, because in fact this t here is the same as this t here, since this is the same row. So guys, right now I have 6 equations, 6 unknown. Let's write them down in order to show you the system of equations here. So guys, these are my 6 equations with 6 unknowns. What are my unknowns? The tension to the right, alpha clockwise, the friction force to the left, AGX to the right, the normal upward, and AB downward. Guys, why am I indicating the directions? Because guys, these equations are written based on these directions. Which means, guys, the value that I'm gonna find are based on these directions. I cannot flip them. Alright? You can flip them at the end of the problem whenever you know their values. But these equations, guys, are written based on these directions. AB is downward since I took this datum and I took AB from this datum to the particle B. AGX is to the right, however, I know that A is to the left, so that's why I took AGX is equal to minus AA and substituted directly here. So guys, alpha here, the value of alpha is based on a clockwise rotation. So remember guys the directions and always put them in front of you. Now, am I done? Is this the question? Let's go back to the question, guys. The question is to determine the minimum coefficient of static friction between the disk and the surface so that the disk roll without slipping. And I have used this without slipping condition in order to find AGX, because I know, guys, if there is slipping condition, I cannot use AGY is equal to 0. AGY will be the minus A normal, and A normal will not be equal to 0 if there is a slipping condition. This means, guys, that I have used without slipping condition to indicate the acceleration of the center of mass, and I have indicated this acceleration as alpha times r. So remember, guys, this equation comes from no slipping condition. But the question is to determine the minimum coefficient of static friction so that this no slipping condition is correct. Where did I use this static friction? In fact, I don't have any static coefficient in these equations. However, guys, I know that no slipping condition is correct if and only if, guys, F friction is less than or equal to mu s times n. Alright? So if I consider that this is no slipping condition, I have always to verify that this assumption was correct by checking that the friction force is less than or equal to mu s times n. If not, this means that my assumption is not valid. This is not a no slipping condition. Maybe it's a slipping condition, and then I have to use this equation instead of AGX is equal to alpha times R. So instead of this equation, I have to add this equation, and in this case, the acceleration of the center of mass is not equal only to alpha times r, which is the tangential acceleration. It's also equal to the normal acceleration. So I have to use ff is equal to mu k n, and this will be my additional equation. So guys, let's go back to the no slipping condition. I am saying, guys, that I need to verify the assumption that f friction is less than mu s times n, which means, guys, I can find mu s. So whenever I know ff and n, I can use the verification that ff should be less than or equal to mu static times n, and this means that n, guys, that mu s, guys, should be greater or equal to what? To ff times n so that I can find the minimum value. So I can find the value of this ratio of f over n, and then I can find this value, and this will be the minimum value for mu s, so that I can say that this is a no slipping condition. That's it. Thank you, guys. Good luck in your final exam.